Confidence intervals are used frequently by engineers when reporting errors on means. One first specifies a desired level of significance called alpha. The 1 minus alpha % confidence interval is then given by this equation. Here, S is the sample standard deviation. Sample is the key word here. N is the number of independent samples, and T is the t-statistic from the student t-distribution. The 1 minus alpha divided by 2 in the subscript denotes the need for a two-tailed test, and the n minus 1 in the subscript is the degrees of freedom for the student t-distribution. This t-value is looked up in a table or obtained from a function in a computer program. An alpha value of 0.05 is encountered often, which leads to a 95% confidence interval. Consider an experiment done to measure the voltage generated by newly developed AA rechargeable batteries after 50 charge-discharge cycles. 9 different batteries were measured, and the data shown here were obtained. The question is, what will you report as the voltage for such batteries after 50 cycles, and what is the error on this value? In Excel, the mean is determined with the average function. One thing needed for the 95% confidence interval is the standard deviation. There are multiple functions in Excel to calculate standard deviation, and it is important to select the correct one. All of them start with stdev. Then, notice that there is a .p and a .s version. These stand for population and sample. The sample version is the desired value here, as the 9 batteries used in the experiment do not constitute all the possible batteries available. They constitute a sample from the entire population. Also notice that there are 2 deprecated or old functions that could be encountered. stdev with nothing else is the sample. stdevp is the population. You shouldn't use the old deprecated functions in any new work. You should use stdev.s for a confidence interval. The .p version is not used in most engineering situations as the entire population is rarely available. The number of values in the sample n can be obtained from the count function. The t-statistic needed is the two-tailed value for a significance or alpha value of 0.05. The Excel functions to obtain this quantity are slightly confusing. Typing t.inv shows 2 functions, one without .2t and one with .2t. The 2t stands for two-tail. The function lacking 2t is a one-tail function. The correct t-statistic can be obtained from both functions if the proper inputs are provided. Using t.inverse requires 1 minus alpha divided by 2 as the so-called probability. The degrees of freedom is the number of points minus 1, which in this case is 8. Using t.inverse.2t requires alpha as the so-called probability. The degrees of freedom is again n minus 1. This difference between the first argument provided to these functions can be confusing, so make sure to understand how to use both. The one-tail function is very similar to functions and tables found in other sources and requires the user to mentally do the 1 minus alpha over 2 math in their head. The two-tail function accepts alpha and does the 1 minus alpha over 2 automatically. There is also a deprecated function called tinv. This function, confusingly, is the same as t.inv.2t, so it accepts just alpha. Once all these values are obtained, the confidence interval is s divided by square root of n times t. When reporting the voltage drop, you need to specify both the mean and the error, and define the error. For example, the voltage drop for the batteries is 1.24 plus or minus 0.03 volts, where the error is the 95% confidence interval. Don't forget to specify what your error is.